Start recording. Invite everybody to jump into the call doc to help us sign in, help us keep notes, capture questions and answer. There's a section down near the bottom to suggest a future call topic. We're pleased to kind of have a joint, a little bit more of a rare thing for us, but a joint call today between data facing and systems facing. So we're going to kind of tag team a little bit of the introduction. So I'm covering the welcome. We're pleased to have everybody here. So I'm going to kind of turn things over to our data facing side to kind of introduce the topic and hand things off to our speakers today.
Cool, I can do that real quick. Hello, everybody. We've invited some folks from Harvard to talk about what they've been building, the Harvard Data Commons, which is I'm interested in myself because I've noticed there's kind of a gap between data management and storage management, and it seems like this this platform might start some of that, which is very intriguing. And the reason why we wanted a joint call is the data facing side, it's a lot of like librarian folks and data management folks who deal with the people side of handling data, whereas the storage side is more systems facing. And so we really just, we need both sides of the equation to just come together to help researchers figure out all their data and storage needs. So with that, I will hand it over to Mahmood, Emre, and Scott.
Thank you very much. So good afternoon, everyone. I'm Scott Yockel, University Research Computing Officer here at Harvard. You're also going to hear from Emre Keskin, who is our University Research Data Officer, and Mahmood, Shad, who's our Associate Director for Research Software Engineering. The three of us are inside of a new group at Harvard University Research Computing, where we're focused on kind of new services beyond the typical high-performance computing and data storage infrastructure that we have existed for quite some time. So we're excited to be able to talk to you today about this concept that we have as a data commons. The three of us are going to talk, so I'm just going to jump right into it. And you can interrupt along the way, or we also won't take the whole time. We should have at least 15 minutes at the end as well to have a conversation with you. And by no means are we experts. We were just trying to say this is what we've come up with so far. So this question will be a question that we pose at the end, but I just wanted to pose it so it's something that you can see and think about along the way. Is, what challenges do you face in the sharing aspects and the publishing aspects of research data? And also when we think about supporting researchers, we typically, especially on the system side, we put our technologist hat on, we provide a lot of tools, right? What do we do that reduces friction? It's mostly what we care about, right, for researchers, because they have an endless amount of tools they can choose from. So today, this is kind of a top level. What we think the problem is that I've been at Harvard now for 8 years, and I see that we have tons and tons of tools that we provide researchers. The tools are across a different part of the landscape. Maybe it's part of planning or data storage or whatever, but there's no interoperability between these tools. And at the time, especially like when researchers are used to using things like Google Docs and all the other application suites like that, where there's a lot of interoperability, they expect this now out of our tool set. And so our goals are really to think about like the ease of the organization for large data. A lot of the tool sets, especially like the older command line tools, are really not geared towards large amounts of data. You can't run a DU on a large amount of data. You can't run a find command very quickly on a large amount of data. There's some stuff like that that just doesn't scale when you get into petabytes of data and then billions of files. Other aspects about this are reproducibility of data, the sharing of active data, as well as publishing data. There's retention requirements, as we all know from NIH and others, to be compliant. there's tracking the provenance of data. I grew up in the computational chemistry space where provenance was something that we were generating, like we generated our own simulations. So I didn't have to think about that. But when you think about social scientists and others who are pulling data sets in and continually improving the data set over time, provenance is a really big part of the research enterprise. And also it makes sense to have like metrics on the utilization of data sets. If we're starting to talk about data preservation and repositories and institutions and how they pay for stuff, we should think about data as an asset. And we can't do that if we don't have metrics. So, oh, and I didn't walk you through the middle, but these are kind of the stages of data, right, in the research cycle. So planning, storing, analysis. The storing analysis pieces, I think, is a lot of what we think of in the research computing space. Management and the disposal. We always hope they dispose of their data so we don't have it up forever, but there's parts that they should keep. And this beginning and ending point, the planning and the management, especially like this data preservation, are the places where we overlap with the libraries. And that's where we think the intersection of the library, these interfaces, is where we have with research computing. So I think at that part, I turned over to Emre to talk through various different aspects of what we're thinking about in the data commons space. Emre?
Thank you.
Yeah.
Thank you. Hello, everyone. I'm Emre Keskin. I'm the University Research Data Officer here at Harvard. And to repeat some of the things that Scott said, when you think about the data lifecycle and each step of the data lifecycle from, say, planning to management to data analysis to even disposal of data. And the thing is that all of these overlap with storing all of this data, right? So because when you start acquiring your data or collecting it or generating it, or somehow you find some data somewhere, you need to make sure that even if they don't end up in the final publication, in the interim, all of that data needs to sit somewhere. And it's not only the raw data, right? There's software, there are intermediate results, there are notes, procedures, metadata, test runs of simulations. All of this needs to be stored. And we have to do data analysis on all of that, because if you are not doing any data analysis, you have just some stuff that's costing you money in your storage. And finally, we have even some requirements to get rid of data, and it needs to be properly managed. And of course, I think this is not news to anyone here. I think every research computing team in different campuses deals with these almost daily. So the problem we see it is that then there needs to be a support that's covering all of these things, right? There needs to be support for data sharing, or more precisely, support for intelligence openness of research data, because we also don't want data just freely accessible to anyone everywhere, right? We need to have some intelligence openness of data. And maybe more importantly, we need to help with the upcoming retention requirements. I recently saw a retention requirement that said that you have to have your data available 7 years after the first publication and 10 years after the last access of data, which might be basically forever, right? So we need to be able to produce support structures for those requirements. So in the next slide, there is also this infrastructure. And of course, all of this doesn't happen overnight. We need proper infrastructure. We need robust tools, robust systems, and more importantly, properly trained research support staff to provide support for data-centric research. And again, I think that it's also no surprise to anyone that bits and pieces of this infrastructure is already built on campuses, and sometimes maybe even duplications, right? There might be 2 different units in the same campus offering the same data repository software deployed in 2 different places, creating inefficiencies. So as you can see in the next slide, what we need is a move towards a data commons. And the concept of data commons, it's not revolutionary or it's not new. It's the idea that we should bring not only data with cloud computing systems, but with services, supports, tools, and applications, and data analysis. and data sharing systems in one place. And that's the problem, right? How do we bring this in one place? And again, I don't think it's, I think that most of the parts of this infrastructure is already installed in many campuses. What we need to do is bring this together. And that brings us to our Harvard Data Commons vision. Our vision is, our main overarching goal at Harvard is nothing but improve researcher experience. We don't want anything other than improving researcher experience. Yes, we want to be able to help with their data management. We want to be help with their data sharing, but we feel that the raison d'etre for Data Commons is to provide seamless data science experience to faculty and researchers. To do that, we already have some systems that are in place, and we are currently conducting a discovery phase to identify more detail what the researcher needs and what will be valuable going forward. We would like to integrate into our systems more analysis tools, more electronic lab notebooks, to basically make it into a digital research ecosystem rather than just commons. And our guiding principles are, the most important is to treat data is the most valuable asset we have. And it's not just an valuable, maybe it's valuable inherently, but we also want to think that data is something that we can extract further value from. This is a huge collaboration at Harvard. There are about 40, 50 people working on it, from libraries, from research computing, from IT, and from the provost for research. We would like to collaborate with our peers, hence we are here. And it's very important to say that we would like to use FAIR principles going forward. So now, Scott, will you give you more details about the current state of what we have?
Thanks, Emre. So in the current state, we're just going to talk a little bit about the tools that do exist. So this is kind of a graphic that's talking about the research computing tools. So on the left, we have Harvard Dataverse, which I'll go into detail in a second, but as a repository, we have things like RSpace, which is an electronic lab notebook. Researchers are commonly using notebooks in the sense of Jupyter and RStudio. We have various different either GitLab or GitHub repositories that they can use that are like university-wide. Glotus, we're actually using on the back end, both in research computing, but also in the libraries, Starfish as a mostly for end use, I mean, mostly for administrative, but also some end user ways to manage data. The other aspects of things, there's classifications of data that happens with its security levels and things like that. There's 3 different kind of storage tiers of data, being active, being kind of more kind of intermediate or medium storage. Like we call it bulk. We call it active, bulk storage, and cold storage. So the ABC of storage. It's kind of what we've come to. So those are the different acts that these are all part of like the research computing enterprise. So beyond that, in the library space, they have a different view of the world than kind of the research computing space. And I would just say like they're broken into kind of largely these kind of 3 different sections, like discovery, management, and preservation. And so 3 things that kind of overlap with each other are, so Hollis is like the discovery package that you would interact with as an end user. That's just for like all sorts of periodicals and books and the typical library management. But other aspects of things that kind of overlap more in the research space are the Dash, which is the open access journal repository, Dataverse, which is the actual data repository, and also down at the bottom here, this digital repository service. This is part of like the archiving and preservation space. So you can see that each of these kind of operate in kind of multi-mode situations, and we'll dive into those just a little bit because we've done a little bit of work to integrate these. So Dash is the open access repository. So there's a huge, it's built upon DSpace, but I would say there's a huge effort across the majority of the campus for every time that somebody goes to publish an article that it also gets deposited into Dash at the campus level, or encourage them to use their own discipline-specific place. So this one's kind of open, and you can see that it's quite large in its capacity. There's another one that existed, which is the digital repository service, or we just call it DRS internally. This is the infrastructure to like more formally take any digital collection and archive it on campus. And the library technology services manages this, and that's part of the Harvard University IT. And they do it in partnership with, of course, the library. And so you can see the different types of things that it does. One of the things I'll just say on the system side, the digital repository service is 2 disk and 2 tape collections. So there's an input disk collection, so it goes on hard drives that then replicates across a different site. And then those do the similar aspect of putting onto tape. And one of those disk and one of those tape options now is actually part of research computing infrastructure. So it's a nice partnership that's been created. And then Dataverse. So Dataverse is a product that the Institute of Quantitative Social Sciences has created. And then there's a Harvard implementation of Dataverse. So not to confuse the two, like one is the open source community, one is an actual application that's managed. So the Harvard Dataverse is an implementation of it. It's open for a lot of people to put their into DOI and to get publication for their data, and it also provides a rich amount of metadata to be searchable. So those 3 things that I just talked about all have their own information and metadata that are not shared previously, but one could understand that Dataverse has the data, and which is not an archiving tool, it's just a data repository, is different than DRS, which is different than Dash, which is a place to put your publication. Anyways, so those are 3 different types of tools that researchers might engage with that were already existing. And so we'll talk about now Harvard, the data commons. So we started to work together behind the scenes across this different enterprise group. And one thing I'll mention that is really, really helpful, and I think this came up on a call not too long ago, was in the concept of what happens when individual people leave. So I wanted to point out that we have executive sponsors across the IT, right, university CIO, the library, and provost for research. We have representation from the central part of research computing, the libraries, the IT, and then various different major parts of the campus when it comes to research computing. Just to point out, for example, like 2 of the executive sponsors, one of the leads, which was the former research data officer, which is now Emre, changed out. I had moved from FAS research computing into the university. We have had different people from the library and university IT and stuff change out over the years from the original ideas of this. So what I'm trying to say is, like, if you create a leadership group that is large and comprehensive, you can have a lot of change, but you can still move forward. You don't lose out on the concept that you're trying to create. So its path may change a little, but you don't completely lose out on it. So in the next step, we're going to talk about a small project that we did was we created a minimum viable product for our first step of the data commons, right? And so Mahmood's going to walk you through the various different objectives and what those were technically. But essentially, I don't think I'm going to cover more on this slide. You're going to see it in the next slides anyway. So I'll take it away, Mahmood, to cover objective 1.
Cool. Thank you, Scott and Emre. So I'm happy to report on the progress of each objective. Objective 1, as Scott introduced, different services for discovery management and publishing of the data. Objective 1 tries to integrate the Harvard research computing environment with different repositories at Harvard to help with transferring data with metadata, which are larger in size. And that process can be done in different ways. When we listed 3 of them and the current status as of February 23. If the researcher wants to upload large data, we will discuss the different sizes in the next slide. But for the direct upload to S3, which currently exists and already at multiple Dataverse installation, can work. Dataverse backend can work with S3. It doesn't have to be AWS S3, any storage that supports S3 protocol. For the Globus transfer, where Globus helps transferring the data from research computing to the storage, like S3 storage, it's in the testing phase and will be available in the upcoming releases. The remote storage keeps the data in remote location and only stores address in the Dataverse that can direct user for direct download from the remote storage. So the backend flow of the data is shown in the next slide. For example, the direct upload to S3, where Dataverse server can receive a request and also provide a signed URL, which can basically provide access control, limited time access to the data to the S3 bucket, or you can use DB uploader for CLI access to download batches of the data. And in this chart, you can see different sizes of the data that each method supports. For direct upload to S3, you can see the range like in the gigabytes. And if you use the Globus transfer, that can provide you with larger size in the data, and you can see the process where the Dataverse Globus transfer app helps researcher in the Dataverse website to locate the endpoints and use Globus service to transfer those data from endpoints to the S3 bucket, and Globus S3 connector helps with providing the access. And also remote storage, which removes burden from the Dataverse servers and just direct user to the original file location, and or can send it to this to a service that enforces the access policy, like Globus API or ODAM trusted remote storage agent. If you want to learn more about each of these processes, you can check the presentation by Jim Meyer at a Dataverse community meeting last year, Globus-based transfer to Dataverse. You can access through the link. And that goes over the details, mostly for system-facing folks who wants to learn more about each transfer. And with each, you can see range of like different size of data from gigabyte to terabyte or even petabytes, and can be used to access the data.
I was just going to say, Mahmood, one of the things that they might not realize with Dataverse is if you haven't installed it before, there was limits before about the number of files and the size of the files that could be used through the direct interface of Harvard or of Dataverse. And so this was getting rid of those limitations and opening up the ability to use Dataverse for a lot larger amounts of data, which means it opens it up for other disciplines. So in the sciences had largely not used Dataverse. It had been very social science centric tool in the past. So that was one of the major accomplishments with this effort. Yeah.
There's a question in the chat about using of the Globus S3 premium connector, if that's what you are using.
So we're doing both. So when you see the direct upload download to S3, that can be done with Globus. You can also just do it with a multi-part S3 upload, and there's not a whole lot of difference in the benefits as far as performance. The thing that we're able to do, it is more efficient, as you can see, like the third bar down here, the Globus transfer to S3, than the direct upload through S3. Because you end up with a cluster, right, sending files and receiving files, that's kind of the gain on the system side of it. The other thing that we're doing with Globus is just the POSIX interface, and that's the bottom one. This remote data reference storage actually via Globus to create, to index all of the files on ingestion, so they all individually show up in Dataverse, and as opposed to like a Globus share as a single file looking thing. So that's kind of the difference as the last one. So you end up with the ability to have a remote data source. So you could have something, say, sitting in your research computing, say, Lustre file system or a tape system that you manage, and have it show up and be ingested through Globus. So you can ingest it through Globus, be indexed, so it's searchable on the metadata side, but then live on a remote data store. which is quite a bit different than having to manage the storage and pay for the storage as the Dataverse, say, operator. So hopefully that helps clear it up. And thanks for a few of those who answered some questions. Like Anna knows some of the insights of this as well.
Cool. Thank you, Scott. Yeah, so for objective 2, the goal was to enable Dataverse for uploading computational workflow, not only uploading, because even before that, users can upload data set and also codes or workflow files, but also help them to discover the computational workflows in Dataverse. So if you consider a researcher, like a research life cycle from explore, refine, and produce phase, where a researcher produces different products throughout the research life cycle, each of those products can be defined as computational workflow if it involves different computational steps to produce data products. And here, for example, the red line is the final product. Could be like results of a paper, dissertation, or data product to share. And we had different people from different departments, library, IT, research computing, to study what is currently available, like Workflow Hub, what metadata terms that we can use, and we came up with the solution to change the current, like add capabilities to current Dataverse and enable users to define metadata and also search for computational workflow. So in the next slide, you can access the documentation in the Dataverse 5.12, and in the documentation, it explains how you can use Dataverse for uploading computational workflow. And there are a few examples already posted for researchers who are not familiar with the standard tools like CWL, also using R Notebook, Jupyter, or other ways to define computational workflow. And in these examples, we try to add more information to make that computational workflow producible, like creating the environment to run this code or notebook and access the data if there's any input data, and to get those output results. So objective 2 is available in 5.12, which is, you can check in the user guide of the Dataverse in 5.12. For objective 3, we have 3A and 3B. 3A is to integrate Dataverse with DRS, digital repository for long-term preservation. Currently, the work that has been done, it's not automated, and they work to enable a curator workflow where to initiate the transfer from Dataverse to DRS. 3B is to integrate Dash, digital access to a scholarship at Harvard, as Scott mentioned, access to open access journals. And if there is any data set associated with that paper, those systems can notify each other, and it makes it easier for researchers to find the linked data, or in the linked data if there is any publication. And they work to basically to connect the linked data notification message between the Dash and Dataverse. And it will be available in the next release of Dash as well. So in the next slide, you can see the, but mostly for system-facing people, if they're interested to see the flow in the backend from the Dataverse and how the DRS import management service works with different brokers to transfer data from the Dataverse S3 to an intermediate storage, and then like for a staging, and then move them to the DRS. And there are some controls to check if there's any failure and notify admin if it reaches to the maximum number of failures. And in the next slide, there is more details, and that shows the communication between Dash and Dataverse. When a researcher submits a paper with Dataverse dataset URI to Dash, and then the Dash linked data notification produces a message for Dataverse LDN inbox, and that can update the metadata on the Dataverse or notify the manager for to update the metadata where there is a linked dataset in the Dash, and that can the Dataverse LDN produces a message to acknowledge the message. Yeah, so as I mentioned, Objective 3A, it's implemented, but the current version of DRS does not support versioning. There's a project to modernize DRS, and there are some public documents on the wiki, Harvard Wiki, which you can see the goals for the project and the areas for improvement and the efforts to make it open source. And the process is not currently automated. And for the 3B, where integration of Dash and Dataverse, it will be available when the new version of the Dash application is up, and it can work to address it.
Thanks, Mahmood. One thing I was going to mention, one of the major accomplishments for us in the minimum viable product exercise, so it was like an internally funded, like small proposal, but we pulled together 40 different people across those 3 different objective groups. It was the largest kind of like collaboration that we've ever put together across like library and a number of research computing groups, IT and other things like that. We also hired external developers and things like that. So it's kind of our first foray into that. And it definitely took us about 3 months to really get organized. We never had to organize so much across the campus. So it built an appetite and an ability for us to like think about what we could do in the future. So one real quick thing is like, there are a few other related initiatives I'm just going to mention. So in Harvard, we have what's called the Research Computing and Data Community. There's about 150 or so people that participate in a quarterly meeting across, it's research computing and data centric, but also a lot of our central IT folks come to that as well. This project, the Data Commons, is something that came out of that, the council, which is like the leads of the research computing groups. And we report into that group regularly, so they hear the updates. And then regulated data strategy is a separate project that is the regulated data side of this, and thinking about how we do that, which I lead. Northeast Storage Exchange was an NSF funded project for a long time that's turned in for the whole of MGHPCC that I was co-PI on. And the backend tape part of what we're talking about with the Data Commons is hosted there. And then the other aspect is that in IQSF, Gary King is the PI for an NIH OTA award for Dataverse. So there's additional work that's happening to Dataverse beyond what I mentioned for the MVP that's happening through the OTA. So these things are kind of intertwined quite a bit. So I just wanted to mention them. But next up, Emre came and joined us just a few months back as the new University Research Data Officer, took the role that, and it kind of expanded it that Mercedes had. And the difference being that instead of just reporting to the university CIO, Emre also reports to the VPR office. And so it's been fun to watch how he's envisioned taking the future ecosystem. So a few more slides left for him to talk about that, and then we'll open it up for more discussion.
Sure, thank you, Scott. Yeah, so as you can see, we have already done a lot of technical data pipeline work, and we have this grand vision of turning Data Commons into what we like to call a digital research gateway. It's rather a digital research ecosystem where you have different applications, different services, different resources. They all come together and populated by the libraries and the university research computing, school research computing offices, as well as the support from the VPR's office. We see it a huge partnership. In the next slide, you can see our grand vision of how this will come together to become this digital ecosystem where a researcher can go in, can find the people support, can find data management support, and there will be already built in data pipelines that will be mostly automated. And we want to build this all on a service-oriented architecture rather than building one monolithic application. So whenever a researcher, for example, asks a domain-specific data analysis tool, we would like to be able to integrate it whenever they need it and bring support to that. And we would like to bring all of this together through behind a web portal. So it's going to be just one ecosystem. Researchers are just going to log into one place, and they will have all the resources and tools they need to do digital science. And then they can share their data. If they need help with policies, they will have all VPR services. If they need help with data management policies, they will have library resources. And the idea is that this will be a one-stop shop for researchers in the single ecosystem. And that's pretty much the next phase of what we are trying to do. We currently have a project that we are trying to get fundings for initial designs of this, which will be followed by implementation of it. So that's our next phase of data commons, to bring it into a digital research ecosystem.
So thanks, Emre. So that's kind of brings us back to the first two questions that we had asked. And I think it's where you can open up into some questions about what is the sharing and publishing issues that you're challenged with, what tooling and things do you envision in this space, maybe compared to what we talked about, or if you want to know more questions about what the tools that we talked about, we're happy to answer those questions. And I see one question that came up earlier that asked about tape. So in the Northeast Storage Exchange, tape is fronted with, of course, disk storage. That disk storage is presented to the MGHPC community only via Globus or MinIO, which is an F3 interface. So it's that interface by which Dataverse, or within the data commons concept, is being communicated to users. So
So there's some other questions kind of wrapped around that, kind of
yeah.
To the backend storage being S3, is it all one place? Is it,
It's a single bucket. Yeah, so it's a single bucket, and the it's through, like, so the ingestion comes in through Dataverse as an application, and it manages the creation of the like the files within S3. So it's not a bucket that is created per collection or deposit. It's a single bucket on the back end. Hopefully that answers what you're asking about. Yeah, and there's a database that within Dataverse that manages permissions and access and things like that. And then there's a database that manages the metadata about all of the collections that you can search through. So
Anna might have answered this already, but is this on-prem or some external provider for the S3?
Okay, so Harvard Dataverse uses as the primary source right now Amazon S3. There's a backup of the S3 bucket that is in the Northeast Storage Exchange, which is a Ceph data store. So there are multiple copies of that, but the primary, like, forward-facing collection is on Amazon S3. You can configure Dataverse how you want. It can use POSIX file system, it can use S3 file system. So it's up to you when you install it, where you put those, and you can replicate across however many sources you want. So now, how the heck do we manage 40 people in collaboration? Well, one of my colleagues, Krista Valadares, she was the project manager. And so this is a very important aspect of the project, is she had to project manage the leadership as well as the 3 different groups. I think the library provided a project manager for the 3 A and B. So I don't think you could pull this off across campus without a project manager, because it is challenging. You have a bunch of people who, like, on the technology side, like, technologists are always very skeptical of each other for just out of tradition, I guess. And and then you have different domain scientists who are kind of also in that space of not understanding the various different terminologies that people are using. So it's important to have kind of a person in the room that is, like, pulling together on the threads that are happening to make sure that everybody's kind of in agreement, that we have the right direction and that kind of stuff. So it was really important that we had a project manager. So I wanted to point that out.
Yeah, there are 2 questions I can answer, actually.
Yeah.
So one of them is NIH DMPS. So libraries has what we can call a task force for responding to NIH DMPS needs. They run workshops, and they even send out surveys to researchers. What do you need in regards to DMPS? How we can help you? And we also made changes into our DMP tool that includes, for example, sample, new NIH DMPS data management plans. So library services provided within that Harvard Data Commons helps with that a lot. The second one is in Harvard Data Commons, we have a specific what we call the ambassadors program that has our faculty champions that are faculty that have some input into this project that is already going on, and they go and talk to other researchers and they get input from them. And me and a couple other people are part of that ambassadorship group. So we collect feedback from researchers by actually employing other researchers directly.
And I guess the other aspect, Emre, in that, how do we get input from researchers, is that we're also, with the advent of university research computing, undergoing an exercise to create kind of our first university-wide strategic plan for research computing and data. And in that process, we will go and interview select faculty across the university and the different schools. And there will be questions about data management and things that Emre asked. So we'll also receive it in that manner.
There's also a question about when you mentioned about 40 or so people involved in the project overall. Have you looked at this in the sense of the number of people hours on the project on a yearly basis?
So I'm not sure it was more each objective needed input about what were kind of the subtasks and what were the things that were the most priority, and kind of like what we needed was to create a very specific statement of work that we wanted to have happen, that developers that were hired as a part of the project were going to develop. So it wasn't that 40 people did the development. I want to make sure that's clear. And maybe Mahmood, you could speak to, because you were leading of one of those groups, like how often did objective 2 meet, and
Yeah,
like
sure.
for what duration?
Yeah, as Scott mentioned, the challenge was people are coming from different domains and different technical backgrounds. For objective 2, where we work on, which was more exploration than straightforward like implementation. So we had weekly meeting, and we increased the meeting frequency, sometime twice a week, to in order to meet the deadline. And when we had the developer actually doing the work, we also add another meeting to go over the development. And it was a great experience, because you hear from different people from library, from IT, from research computing, and that helped to come up with a solution that met the MVP goals in the project.
Yeah, and how long did the group meet for when you guys were doing
we started in August 2021, and we finished by the end of June 22.
Yeah. And also, I would also say to that this is also groups of people who are already meeting about these concepts, but they were meeting mostly individually, like within their own units. So some of what was happening is pulling together a wider meeting that wasn't happening yet. So it wasn't that we were adding a huge amount of burden to people's time. I mean, there definitely was, but I'm just saying that like it wasn't a significant shift of what people's typical meeting schedules and stuff were. We also tried to tap into people who weren't, we definitely wanted to tap into those that were kind of at the management and individual contributor space that had a lot of information and a lot at stake about these topics, as opposed to having kind of the director level meet. On the director level side, we only met like once a month for like 30 minutes, just to check in the general direction of things. So
there's another question asking about maybe your footprint size in S3 and maybe budgeting going forward.
Yeah, so on the Dataverse side, and I might be a little dated on this. I don't know if Anna or somebody has like more up to date. It's in the like 40 terabyte range, 40 or 50 terabyte range. And that was mostly, it wasn't large in the sense because at the time, the social science space, you can only upload like up to like a terabyte or I think there's actual up-to-date metrics. there was a limit to the capacity that you could upload as a single collection or the number of files. So you didn't have a lot of the large, like astronomical or genomics types of stuff was not a part of this. And that was also the reason why we wanted to look at tape as being an option. And since the Northeast Storage Exchange was something I was involved in leading, to come up with a mechanism of Globus being that interface and a remote data share, now we could have collections that are outside of Dataverse and their cost so like a person could have, like a researcher, like a faculty could buy tape for the NSC tape and have their own collection. And all they have to do is create a share of it that is then becomes like a read-only version that they then expose more or less through Dataverse. So Dataverse would ingest it through the metadata, but then leave the data in place. So it changes the funding model when you do that you don't have to have it be a part of Dataverse.
Deb's got another question here of any thoughts yet on who will lead the operation, lead this operationally after this project phase?
So the project phase was for the MVP. So because we tied together tools that already existed. So like Dash and DRS are library technology service, so of the central IT, like those are their products that they manage. Dataverse, the infrastructure the library runs, IQSF, Institute of Quantitative Social Science, runs the service. So those didn't change. All we did was add functionality to those so that the metadata is shared across those, and an end user can view and search across the various different aspects of it. That was for the MVP. The larger context of thing that Emre provided is a conceptual thing that we're applying for funding for. And I think there's kind of two aspects of it, like who would help a person use it. We have a huge collection, or sorry, a huge community, not a collection. We have a huge community of research computing facilitators that can help guide people through these tools. The infrastructure itself, I think, is still a little bit to be determined. And part of that is also that the University Research Computing as a department that I'm in charge of is still fairly new. Like we just started FY23, like in July. So I don't really have a full answer for it, but I was just trying to poke at some of the threads that we already know about. Hope that helps, Deb. So Venice asked about, have researchers taken the idea of releasing metadata on Dataverse early? That's totally viable. And that's actually, so a long time, Merce and I used to meet all the time for coffee and talk about all these kinds of aspects of things. That is something that I think should be done. And I think at least it could be done internally. So there was the concept early on that you could get a DOI, or you would publish your data set into Dataverse without getting a DOI and have it be more or less registered. And then that way the metadata and all the aspects of it would be known. And one of the things that we could do with that is intertwine Dataverse and Starfish. So Starfish is a data management tool that you would scan your files, create a database out of it, and then system administrators could create action, and you could add tags to files that would then take action. So there was a way to do that kind of stuff together. But so I think in the grander scheme of things, that's part of the deciding what we want to do. But I really wish we could get to researchers the idea of kind of registering, I guess I would say, their data sets as they're active and how they're changing, because then we can make decisions and create actionable things with like policy kind of things with their metadata that they create. So I still think at the university space there has to be a really big carrot to have researchers spend more time doing something than their research. And so maybe if the carrot was you get to archive your stuff for free at the end, if you use these principles like around data management, that might be the way to go. But we have to convince our leadership to pay for that, of course.
I can answer one of the questions by Yogesh, and the question is, if the part of data is used for publication, in that case, do you create a separate copy of it, or you tag update metadata for the whole data set? I mean, currently, if the size of data is manageable, you can publish data set in the Dataverse. If it's large, through one of those methods, you can point to the data, either leave the metadata in Dataverse and access through the remote storage, or if it's going to be on Dataverse S3, it has to be copied over. But the goal is you publish the data set which is ready to go, and if it's part of your active research, that has to be separated. And the metadata is associated with only the data set that you are publishing.
I mean, Chris asked the question earlier, I don't know if we addressed it. Do you host large public data sets to reduce wait times for downloads? I would say that could definitely be part of, in the Dataverse side that is funded by NIH for the generalist repository. They're part of that program, that we would be benefactors of that, because there could be NIH data sets that are a part of that, and then they would be then hosted locally to us. But that's kind of a consequence of that. But the concept of, do you host large data sets about reducing times for downloads, I mean, I think each research computing group at Harvard does a little bit of that. So I know in FAS and I know in the med school, they do have collections of large data sets that they keep in their data store. And it's mostly not to reduce times for downloads, but to reduce the amount of copies of those large data sets that exist. So they create these kind of open repositories that people can use, kind of the read-only place. But they're not findable unless you just ask. And I think that's the point of the data commons, would be to have a way that's easier discovery and easier access to those types of data sets, or any data set like that a group wants to publish, right? When I say publish, I mean make available to, say, researchers on campus or collaborators, like prior to publication. Part of the way Dataverse is fund, so that the way Anna put up Dataverse, the Dataverse funding that comes in through Institute of Quantitative Social Science is a lot for like the development of the code base. The Dataverse funding to run Harvard Dataverse is something that's in the library's budget. Just to be clear, it's like the back-end infrastructure part of it.
All right, so we're getting close to about 5 minutes to the top of the hour. Do we have other questions anybody would like to surface and put forth to our speakers?
Or if you want to like throw out some tools that you guys use in this space, that's also helpful for others to know.
I have a really high level question, Scott. This is Anita Schwartz from the University of Delaware. How you doing?
All right.
Can you guys hear me?
Sounds good.
Okay, so this is just a high level question to Scott. I know that we've talked about this many times over the years about a coordinated effort such as this. If you think back, I mean, many of our institutions have somewhat of a distributed type of service or support. And so thinking and looking at what you've accomplished, can you, I guess, just at the highest level say when you thought you started putting this together? Because I know your role has changed as well over the years, but primarily when you did, who the key people were. Was it those execs that you listed on that chart before? And then from that beginning till now, how you felt, what made it all come together? Were there policies? Were there other things that came into play as far as grants, requirements, types of things like that, that really allowed you to have that effort behind the support at the highest level at the university?
Yeah, that's a good point. So I guess it was in 2018. So I started reporting a portion of my time into the CIO's office as well as Mercedes Cross's.
Right.
And so in that process, we would meet every week for coffee. there was a lot of like, Harvard is very meeting centric. It's like committees upon committees. And so there's in that you create a community of conversation that's happening across a lot of different threads. And so we're saying like we see each other in all these meetings, but we don't have time to talk. And so she had a lot of ideas about data management, data provenance, and all of that from her work all around Dataverse, but also with across the data management communities that were at Harvard. And then I had like my infrastructure hat on, like I can build big infrastructure, I can do big data and that kind of stuff. From that kind of aspect, I was also involved in a couple of grants to build an internal on-prem cloud and also that staff and tape storage. So we started to like formulate what could become something of a data commons, but it couldn't just be the two of us. And so we were talking about who else do we need to pull in, who else has ideas in this space. So we pulled in the other research computing leads. So we were representing two parts of it. So we pulled in the business school and we pulled in the med school. So that represented the 4 different groups that provided technology services to researchers on campus. Then from that, we pulled in Piotr, who's the lead person for structural biology grid, SP grid, who a lot of people consume their software. He's also the head of Boston Children's Research Computing. And he's also medical school faculty, so he brings in that aspect. And we also, at the same time, Stu Sneidman came to be the new, came from Stanford Libraries to become the new managing director of library technology. So that became kind of a brainstorming group for about a year. From about 2018 to summer of 2019, we were going to submit an internal proposal, and then that funding source for internal proposals didn't happen that year. And then we started picking away. So actually, after that, we decided we would have a workshop, and so we invited. It was like the beginning of the pandemic, and we divided, I think, 40 different people, and we had like an online workshop. And I think that's what we would like to do again. And I think that's what we would like to do, is to build a community of some peers who are very interested in like kind of chipping away at what this ecosystem should look like. As you saw, we only just strung together like 3 different tools or 4 different tools, I guess, if you had Globus to it. And that took us about 6 months to do that work. It took us 6 months before that to plan what the work was. So I'm just trying to, but there's a lot more that can happen. So leadership across the campus was key. Leadership outside of just research computing to involve the libraries. Then we started pulling in other people from the libraries themselves, not just the technology side.
That's
and
great.
then you
So
have to,
basically, you're saying 7 years at this point, from 2018 till
I guess
now.
that much time is
No, I'm sorry, not 7, 2018, 5 years, 5 years.
yeah, 5 years. So
Yeah. I mean, no, that's really kind of what I wanted to get, like a cultural feeling, like what's the cultural shift?
The
that we have
pandemic
to
set
think
us back a
about.
year, but yeah, I would say
Okay.
4 years from nothing to the concept, to some people to validate the concept, to apply for funding, to get organized across the university and actually do something. That was kind of how those years went by. And I think it also builds trust with faculty that we can do something, right? That's where we're at now. Like, can they start using what we've done? Can we then, like Emre's vision of like, can we like make this more of a better ecosystem and more of a platform, a launching place? It needs to also not just be technology, it has to be a program. Like, there has to be people behind this stuff. The people need to know each other across the campus to provide a seamless experience. So that's a big undertaking still left to do.
Great, thank you so much.
Yeah, and I mean, libraries does a lot of research support services that are fantastic, that helps what we are doing. And they are doing almost all of it independently from what we do here, but we use their services to help researchers. So that's also important.
Yeah.
Well, we are at the top of the hour. Be mindful of number of people needing to get to another meeting. We do very much appreciate time and effort our speakers have put into preparing this for us. Good questions, discussions that we've been able to have. Maybe if I can nudge one of the speakers to send us a link or a copy to the slides, we've love to be able to share that with the group. We appreciate
Yeah,
everybody's
that's already-
participation and attendance.
Yeah, I think Denise has the copy of the slides already.
Okay, that's great.
I do.
Um,
Thanks, Scott. Yeah, I'll get those out.
With that, thanks everybody for attending, and we'll wrap things up.
Thank you,
It's great to
everyone.
see you all. Thank you.
Thank you.